Dear friend, this is an interesting episode. In this episode, we are going to discuss states of matter. As we all know, water exists in three states, that is, solid, ice, liquid, potable water, gas, steams, vapors of water. In these three states, water has different physical properties but same chemical composition, that is H2O. Also, characteristics of these states of water depend on the molecular energy and how molecules aggregate. As molecules changes its physical state from liquid to gas, gas to liquid or solid to gas, etc., there is no change in chemical properties of the substance, but some changes may occur in rate of chemical reaction. Let's discuss about intermolecular forces. Intermolecular forces are the forces of attraction and or repulsion between the interacting particles, that is atoms or molecules. Dutch scientist J. van der Waals explains deviation of real gases from ideal behavior with intermolecular forces. So intermolecular forces are also called as van der Waals forces. Example: hydrogen bonding, which is strong dipole-dipole interaction. Dispersion forces. If an atom gets instantaneous dipole, that is, atom has more electron density in right or left hand side, then its nearby atom becomes induced dipole. So these two temporary dipole attracts each other. These attractive forces between these two temporary induced dipoles is known as dispersion forces. As these forces were first proposed by F. London, so these forces are also known as London forces. Dipole dipole force. Dipole dipole forces are the type of forces acts between the molecules which have permanent dipole. Dipole of these molecules possesses some partial charges, that is donated by delta positive or delta negative. Example: HCl molecule, where H possesses delta positive and chlorine possesses delta negative, because chlorine atom is more electronegative than hydrogen atom. So H have delta positive while Cl have delta negative. Dipole induced dipole forces. These attractive forces act between polar and non-polar molecules, where polar molecule have permanent dipole which induces the dipole, and non-polar molecule by deforming electronic cloud of non-polar molecule. As polarizability increases, strength of the attractive interaction also increases. So in dipole induced dipole forces, one molecule is polar molecule having its dipole, while other is non-polar molecule which is induced dipole. So attractive forces between this polar and non-polar molecule is known as dipole induced dipole forces. And also, as the polarizability increases, the strength of attractive interaction also increases. Hydrogen bond. It is a type of dipole-dipole interaction present in molecules with high polar NH, OH, HF bonds. Let's discuss thermal energy. Thermal energy is the energy of the body arise due to the motion of its atom or molecules. Thermal energy is directly proportional to temperature of the substance. Intermolecular forces versus thermal interactions. Intermolecular forces make molecule of the substance keep together, while thermal energy of the substance make molecule keep apart. These two, thermal energy and intermolecular forces, decides collectively the states of matter. If intermolecular forces predominates, then gas, then liquid, then solid. If thermal energy predominates, then solid, then liquid, then gas. Means if attractive forces are more than than matter found in solid state, and if thermal energy is much more than matter found in gaseous state. What is troposphere? It is the lowest layer of the atmosphere held by the surface of the earth by gravitational forces where we live. It contains O2, CO2, N2 and water vapors. Gaseous state. Only 11 elements: hydrogen, oxygen, nitrogen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radium exists in gaseous state under normal conditions. Characteristic physical properties of gases. Gases are highly compressible. Gases exerts the equal pressures in all directions. As compared to solid and liquid, gases have much lower density. Gases don't have definite fixed shape and volume. Gases mix completely and evenly in all proportions. Gas laws. There are so many gases laws, so we discuss them here. First is Boyle's law. Boyle's law is also known as pressure volume relationship. As per Boyle's law, at constant temperature and fixed amount of gas in number of moles, its pressure varies inversely with its volume. Mathematically, at constant temperature and constant number of moles, that is at constant T and N, P is directly proportional to 1 by V, and P is all equal to K1 into 1 by V, that is equal to K1 by V, where P is pressure, V is volume and K is proportionality constant, and value of K1 depends upon pressure and volume. Also, K1 is equal to PV. According to above relationship, product of pressure and volume remains constant. If we fixed the amount of gas at constant temperature, you can learn more at our website www.chemistrynotesinfo.com about chemistry. Let's continue our discussion. P1 V1 is equal to P2 V2 is equal to constant. Also, P1 by P2 is equal to V2 by V1. As we know, density is equal to mass divided by volume, that is D is equal to M by V. So, V is equal to M by D. Also, with the help of above discussion and above equations which I discussed, P is equal to K1 into D by M. So, D is equal to M by K1 by P, that is equal to K dash P, where K dash is equal to M by K1. Charles law. This is also known as temperature and volume relationship. As per Charles law, at constant pressure and fixed volume, as per Charles law, at constant pressure and fixed mass of gas, volume is directly proportional to absolute temperature. I explain again. As per Charles law, at constant pressure and fixed mass of gas, volume is directly proportional to absolute temperature. Mathematically, at constant P and N, V is directly proportional to T. Also, V is equal to K to T, where K2 is a constant. Thermodynamic scale. Kelvin scale of the temperature is known as the thermodynamic scale, which is utilized in many scientific works. Kelvin scale. To obtain temperature in Kelvin scale, we add 273 6.15, generally 273 in Celsius temperature. That is, K is equal to 273.15 plus degree Celsius. Gay-Lussac's law. This law is also known as pressure and temperature relationship. According to Gay-Lussac's law, at constant volume and fixed amount of gas, pressure is directly proportional to temperature. Mathematically, at constant V and N, P is directly proportional to T. Also, P is equal to K3T, where K3 is a constant. Avogadro's law. This law is also known as volume and amount relationship. According to Avogadro's law, equal volume of all gases under same condition of pressure and temperature contains equal number of molecules. V is directly proportional to N, and V is equal to K4N, where V is volume, K4 is a constant, and N is number of moles of gas. Avogadro's constant. 1 mole has 6.022 into 10 to power 23 number of molecules, which is called as Avogadro's constant. I explain again. 1 molecule has 6.022 into 10 to power 23 number of molecules, which is called as Avogadro's constant. As we know, mole is equal to mass divided by molar mass. So N is equal to M by capital M. Then from above equations, V is equal to K4 M by M, and M is also equal to K4 into M by V, and M also equal to K4 D. Where M is molar mass, where capital M is molar mass, small m is mass, and V is volume, and K4 is constant, and D is density. You can, during listening this podcast, also open our website www.chemistrynotesinfo.com, and in section 11th you can open this chapter to see equations as I dictate for understanding very clearly, or just listen this lesson and then go to website and just read that chapter once, so you understand very well. Ideal gas equation. Combination of three laws, Boyle's law, Charles' law, and Avogadro's law, gives a single equation, PV is equal to nRT, called as ideal gas equation. Mathematically, according to Boyle's law, at constant T and N, V is directly proportional to 1 by P. According to Charles' law, at constant P and N, V is directly proportional to T. According to Avogadro's law, at constant T and N, V is directly proportional to N. And as per these three equations, V is directly proportional to NT by P. So V is equal to RNT by P, or V is equal to nRT by P. Also PV is equal to nRT. Then R is equal to PV by NT, where R is a gas constant which is same for all gases and known as universal gas constant. And equation 6, that is PV is equal to nRT, is known as ideal gas equation. Equation of states. Ideal gas equation is also known as equation of states because it gives relationship between four variables, that is P, V, N and T, which describes states of any gas. If pressure, volume and temperature of fixed amount of ideal gas changes from P1 V1 T1 to P2 V2 T2, then P1 V1 by T1 is equal to nR, and similarly P2 V2 by T2 is equal to NR. So from these two equations we get P1 V1 by T1 is equal to P1 P2 V2 by T2. So this equation is called combined gas law. Density and molar mass of gaseous substances. As per ideal gas equation, PV is equal to nRT, then N by V is equal to P by RT. On replacing N by M by M as mole, N is equal to mass, M molar mass is equal to capital M, V obtain M by V is equal to P by RT. So we obtain M is equal to dRT by P, where capital M is molar mass, small d is density, R is a gas constant, T is a temperature, and P is pressure. Dalton's law of partial pressure. According to Dalton's law of partial pressure, total exerted pressure by mixing of all non-reactive gases is equal to the sum of partial pressure of all individual gases. At constant temperature T and volume V, P total is equal to P1 plus P2 plus P3 and so on, where P total is equal to total exerted pressure of mixture of all gases, and P1, P2, P3 etc. is pressure exerted by individual gases, known as partial pressure. Now we discuss aqueous tension. It is exerted by the saturated water vapors, that is P dry gas is equal to P total minus aqueous tension. Partial pressure in terms of mole fraction. Let at T temperature 3 gases of volume V exerts the partial pressure P1, P2, P3, then as per ideal gas equation, P1 is equal to N1 RT by V and P2 is equal to N2 RT by V, P3 is equal to N3 RT by V, where N1 into N3 are number of moles. And also according to Dalton's law of partial pressure, P total is equal to P1 plus P2 plus P3, or P total is equal to N1 RT by V plus N2 RT by V plus N3 RT by V is equal to N1 plus N2 plus N3 RT by V. So P1 is equal to X1 P total, similarly P2 is equal to X2 P total, and P3 is equal to X3 P total. Then general equation is written as Pi is equal to Xi P total, where Pi is partial pressure of ith gas and Xi is mole fraction of ith gas. Kinetic molecular theory of gases. The postulate or assumption of kinetic molecular theory of gases are as follows. Gases contains atoms or molecules as large number of identical particles. These atoms or molecules are at large distances from each other, so that volume of gases is very high as compared to actual volume of all molecules of gases. Great compressibility of the gas is explained by these assumptions. Gases occupy all available space by expansion because at ordinary pressure and temperature there are no attractive forces between gas particles. Gas particles always move in random and at constant motion because if gas particles are at rest, then they occupy fixed positions, then gas would have fixed shape. This is not observed at all. Gas particles move in straight lines in all the possible directions. During random motion, these particles collide with each other and also collide with the walls of the container of the gas. As a result of this collision of the gas particles with wall of the gas container, pressure is exerted by gas. Collision between the gas molecules is perfectly elastic
It means total energy of the molecules don't change, that is, it is remains same before and after collision. Individual energy of the molecules may change due to exchange of energy between the colliding molecules, but sum of the energy of all molecules remains same. Molecule of the gas move with the different speeds and their individual speed goes on changing due to collision of molecules, but at particular temperature distribution of speed of molecules remains constant. Kinetic energy of the molecules or the gas is directly proportional to absolute temperature, because on heating gas at fixed volume its pressure increases. As on heating, molecules moves with more speed and strikes with walls of the container more rapidly, so exerts more pressure. Behavior of real gases. Deviation from ideal gas behavior. When we do different experiment, we find that real gases don't follow PV is equal to nRT equation for ideal gases. So real gases don't follow Boyle's law, means if we plot graph between PV and P, then we don't get parallel straight lines at all pressure with x-axis. Liquefaction of gases. The process of converting gas into liquid is known as liquefaction of gases. The highest temperature at which gas starts liquefying is known as critical temperature. Volume of 1 mole of the gas at this critical temperature is known as critical volume. Pressure at this critical temperature is known as critical pressure. Gases are cooled below their critical temperature for the liquefaction of gas. When we apply cooling as well as compression, gas liquefies easily. Liquid state. Intermolecular forces in liquids are stronger than in gases. Liquids have definite fixed volume and they can flow and take the shape of the container in which these liquids are stored. These this episode is brought to you by www.chemistrynotesinfo.com. Vapor pressure, viscosity, surface tension are some physical properties of liquids which we discuss in this lesson. Vapor pressure. Vapor pressure is the pressure exerted by the vapors of the walls of the container containing liquid is known as vapor pressure. Vaporization depends on the temperature. Vapor pressure at which equilibrium is achieved between liquid phase and vapor phase is known as saturated vapor pressure or equilibrium vapor pressure. Boiling is a condition of free vaporization, means vapor extends freely into the surroundings. Boiling temperature at 1 atmosphere pressure is known as normal boiling point. Boiling temperature at 1 bar pressure is known as standard boiling point. Temperature at which clear boundary between liquids and vapors disappear is known as critical temperature. Surface tension. Liquids tends to minimize their surface area because molecules of the liquids on the surface experience net attractive force towards the interior of the liquid. This characteristic property of the liquid is known as surface tension. Example, mercury do not form thin film and capillary action. Viscosity. It is a measure of resistance to flow that arises due to internal friction between the layers of fluid or liquid when they slip over one another during the flow of liquid or fluid. I repeat, viscosity is a measure of the resistance to flow that arises due to internal friction between the layers of liquid or fluid when they slip over one another during the flow of liquid or fluid. Force required to maintain flow of liquid layers is F is equal to NAdU by dz, where A is area of constant, du by dz is velocity gradient, n is coefficient of viscosity, SI unit of n is Newton second per square meter. CGS unit of n is poise. You can learn more about chemistry from our website www.chemistrynotesinfo.com. This episode is brought to you by Chemistry Notes Info learning platform. You can learn and increase your knowledge with this podcast series. So do follow and subscribe this podcast series. Thank you to listening this episode.